Okay, this is that formula. Okay, so the I is calculated by the formula voltage divided by our ZS. Okay, the T is our disconnection time. We get this from disconnection graphs in the appendix appendix 3 in BS 7671. Depending on which protected device depends on which table we look at. Does that make sense? And then the K comes from tables 54.2 to 54.6, depending on what type of conductor you're using for the earth. Okay? For this, we'll be using table 54.3. When you look at the title of it, okay, it states values of K for protected conductor incorporated in a cable or bunched with cables. Each one of these tables is for a different scenario. Okay. Can you all see table 54.3, those of you with the red books? Yep. Okay. Looking at that table, can you see where it says copper? Okay. And where it says copper, it's got 115/300. Is it? Oh, 103 is it? Okay. The 115, do you say 103? Yeah. 103. So, what we're looking at here is
About 300.
the 103 is for a cable above 300 mil squared. Okay? So for us, K is going to be 115, isn't it? Do you all match up with that? Okay, most commonly for most calculations you'll ever use this for, K is going to be 115. Okay? So, I can also now work on my I, which is going to be my voltage divided by my ZS. So if I do 230 volts divided by 1.40, what will that equal?
$164 to
164.2. Okay, what we'll do is we'll keep that simple, we'll keep it as 164. Okay, and that will go in as a squared number. Now for the next bit, I'll actually get the disconnection graph up on the board for us. Okay, it will just take me a minute just to get there. Page 370. Okay.
What's that graph called again? I forgot, you told me.
It's a...
Oh, you said it last lesson, I
I
forgot.
did say it last lesson, the word's actually just gone to my head. Logarithmic. That's it. Okay? The logarithmic graphs are actually one of the more complicated graphs to read. Okay? The simplest method for the first protocol is to compare my fault current to the little chart on the right hand side. So for my protected device to reach a disconnection time of 0.1 seconds, what size protection device are we going for? 16 amps. So how much fault current does it need to actually disconnect in 0.1 second?
1 second, yeah.
Well, in top graph, circular could be on in 80.
Yeah, with type B. So if you look at this, the first protocol I'd always recommend going to is to look at this little piece here. Should be page 370.
Yep.
Have you found it? Okay. B type RCDs and MCBs.
Yes. 16 amps.
It's because there's some people still looking. So we're looking at 16 amps. So a 16 amp breaker to achieve a 0.1 second disconnection time only needs 80 amps.
Yeah.
Is our fault current above 80 amps? 164 amps isn't above 80 amps. It's above it, isn't it? So remember what I said last week was you can't get any faster than 0.1 disconnection time, can you? It's like me trying to say to you that a 0.1 versus a 0.01 second is and that. Who can tell me which one was quicker? Right? It's fucking impossible, isn't it? So we go straight for this table, and if we're above this, I know I can put my disconnection time down as 0.1 seconds. Because it only needs 80 amps to disconnect in 0.1 seconds. We've gone past that, so we're going to chuck more current at it. In real world terms, it means it would actually disconnect faster, but we can't quantify that in our calculations. Does that make sense?
Yeah.
Okay, so in my formula, I'm going to put down my disconnection time as 0.1. Anyone want to have a go at putting that through their calculator and see what we get? What are you all managing to get? If you're doing it on a simple calculator, you'll need to calculate the top first.
0.40.
What sort of calculator are you using? A scientific one?
Chinese one of these got. See, see you then.
CE, Chinese export.
Yeah, see you.
Everyone managed to get the same as what I've got on the whiteboard, on the smart board?
Mine's slightly different, but that's because of like the decimation and the rounding up.
You put the 0.4, did you?
Yeah.
Okay. That will change it slightly, but nothing.
Within the terms of the marking scheme, that's
It would be acceptable. So, this formula only applies to this scenario. Okay? In this scenario, it means that 0.45 means that our 1.5 mil earthing conductor is suitable because it's bigger than the answer. Okay? It means that in this scenario, that the 1.5 mil conductor will be suitable. It doesn't mean I can then go and install a 0.5 conductor, because what will that do to my ZS? It'll change it, won't it? It'll increase it, which means what's going to happen to the current? It goes up or down?
down.
It goes down, doesn't it? As resistance goes up, the current will come down, which means that this quantity in the formula will change. When that changes, it then changes the disconnection time, which means you get a completely different answer. So this is only, in this scenario, a 1.5 mil conductor will be suitable as we've calculated this answer. Okay? Does that make sense?
Yeah.
Please take pictures of it. Okay? And if you enjoyed all of this, they do a whole qualification just on design and verification. Anyone want to have a go?
All the book already, let me have a look.
I'll give it then.
Basically, everything we've done tonight is what's in 2 questions.
What page was it for?
And that's worth about a third of the marking for the level 4 design paper.
What page was
Being
it?
able to go through,
370.
page 370. Okay.
I think we need the student's guide to the 18th edition. That's what we need. I think that's about 700 pages.
Is this where I go? If you go on campus, okay, this little website that I'm on now, okay, you've all got access to it. On this website, you've got access to all the IET publications, including the student's guide to BS 7671, including the 7 guidance notes, because it's such a complicated book, they've had to publish 7 guidance notes, as well as an electronic version of the on-site guide as well. Okay, all you've got to do is when you log into Canvas is to click on the LRC tab, and then click on electrical installation, the IET tab, and then create an account with your college email, and you've got access to it all.
Simple, huh?
I know. You've seen how long it takes me to get through it all to get on it here. But if you're interested in any of the other stuff and you want to read into things like EV charging and things like that, it's all on there. Okay? You've all got so much resources at your fingertips on Canvas that you should start using it to help you with revision, if you can access it. Hopefully we'll get you on the computer tonight. Okay? What's that?
The only thing we don't have is time.
No one ever has time. There'll have plenty of time when you're dead.